right, this video is going to cover Module 4, Homework 2, talking about complex numbers. So our last section for this test. So imaginary numbers is going to be like our one special case for this section. So we have I. I is the same thing as the square root of -1. Notice it's only the square root, it's only 1, and it's our only special case. So it's really important that you know that I is the square root of -1. So if we have I is the square root of -1, if we square both sides, that way the square and the square root cancel each other out, we get that I squared equals -1. So that'll tell us I squared is -1. So a complex number is one that can be written in the form of a plus bi, where a and b are both real numbers. So the imaginary part is this I that we're looking at. So imaginary part is the b. And then our, look at something real quick. And then our real part would be the a. So this would be our real part. So that'd be a. And then the I tells us that it's imaginary. So the b part would be our imaginary part. So if it asks you for the real coefficient, that number out front would be our real, or sorry, for our imaginary part, our imaginary coefficient. I was making sure to use the right words that they used. Remember, coefficient means the number out front. So the number in front of the I is our imaginary part, and then the A would be our real part. Paper sticking. All right, so let's write our first example. Write 6 plus 4i divided by 2 in standard form. Remember, our standard form is our a plus bi, so where a is a number plus b is a number, and then I is our imaginary. So 6 plus 4i divided by 2. They're both being divided by 2, so I can split it up and say 6 divided by 2 plus 4i divided by 2. 6 divided by 4 would give us 3, plus 4 divided by 2 would give us 2i. So 3 plus 2i. That's in our a plus bi form. So now let's simplify the square root of -45. So in Module 3, Homework 1, we said, okay, it's a negative underneath the square root. We said DNE does not exist. Well, now we are going to simplify it. So now we can't put DNE. We have to go through and simplify it further. So it is the square root, so we're looking for 2 of a kind. So let's break up -45. So we know it's -1 and 45. The square root of -1 is our special case, so I'm going to go ahead and circle that for now. We know 45 is 5 times 9. 5's done, it gets circled. 9 is 3 times 3. 3's done, it gets circled. 3's done, it gets circled. Remember, however you break up 45, you'll get the same 3 times 3 times 5 in the end. So underneath the square root, we have -1 times 3 times 3 times 5, all of our circled numbers. So we have the square root. So because it's the square root, we are allowed to use I. So the square root of -1, this is our one special case. We know the square root of -1 is I, so it's going to come out as I. Just one -1, because that's going to be our I. Square root of -1 is I. It's the square root, so we're looking for 2 of a kind. So these two 3's are coming outside the radical. That poor little lonely 5 doesn't have a pair to come out with it, so it is left by itself underneath the radical. So outside the radical, we have I times 3, which would be 3i. Square root of 5, and that'll be our final answer, 3i square root of 5. Let's do the next one to simplify negative square root of -147. This negative's out front is just going to stay out front. -147 is -1 times 147. -1's our special case, so we're going to circle it. 147, let's see, I know it's not divisible by 2, but 147 divided by 2 gives us an ugly decimal, so that's not going to work. 147 divided by 3 would give us 3 times 49. 3's done, it gets circled. 49 would give us 7 times 7. 7's done, it gets circled. So this negative's out front, it's going to stay out front. It's just like -1 times the square root of -1 times 7 times 7 times 3. That -1's out front, it's going to stay out front, times the square root of -1, which is going to come out as our I. That's our special case. It's the square root, so we're looking for 2 of a kind. So these two 7's are also going to come out of the radical, and that one poor little lonely 3 is left by itself. It's going to stay underneath the radical. So outside of the radical, we have -1 times I times 7, so -7I square root of 3, and that'll be our final answer for that one. All right, next page. Perform the indicated operation and simplify. Express the answer in terms of I as a complex number. Remember, a complex number would be our A plus BI form. All right, so square root of -3 times the square root of -48. So they're both square roots. I can write it underneath the same square root. We have -3. Let's go ahead and break this down. So -3 is -1 times +3. -1's our special case. We're going to circle it. 3 is already broken down as far as we can go, so we're going to circle that as well. -48 is -1 times 48. Again, circling -1. 48, let's do 4 times 12. 4 is 2 times 2, so those get circled. 12 is 2 times 6. 2's done, get circled. 6 is 2 times 3. 2's done. 3's done. So underneath my square root, just that way I kind of have it organized. I have 2 -1s, so -1 times -1. I have 1, 2, 3, 4 2's. And then I have my 2 3's. Just kind of putting it more organized in order underneath the radical, putting it all together. Remember, it's both square roots, so I can write it underneath the same square root. So it's the square root, so we're looking for 2 of a kind. So these 2 -1's are going to come out of the radical, not as I, because there's 2 of them. It's going to come out as -1, just like a normal pair. So now these 2 2's are going to come out of the radical as 2. These 2 2's are going to come out of the radical as 2. These 2 3's are going to come out of the radical as 3. Everything came out of the radical in a pair, so nothing's left underneath the radical. So you have -1 times 2 times 2 times 3. And that will give us -12. And there's no I, so I don't have to really worry about the complex number. We can just leave it as -12. All right, let's do the next one. So simplify negative square root of, simplify the square root of -1 divided by the square root of -1 times the square root of -6. All right, so let's a couple ways you can kind of go about this. Oh, 1 second. I'm trying to think of the best way to explain it. Okay, so let's talk about the top. Square root of -1, which we know is our special case, is I. So yeah, I is the square root of -1. This is our special case. On the bottom, just like we did up here, they're both square roots. Let's try underneath the same square root. -1 times -6. -1's already broken down, so that's circled. -6 we know is -1 times 6. 6 is 2 times 3. So up top we have I divided by the square root of -1 times -1 times 2 times 3. These are 2 -1's underneath the radical, so it's coming out as a pair. It's coming out as just -1. So up top we're left over with I. On the bottom we're left over with -1. Underneath the square root, we're left over with 2 times 3. So we have I over -1 square root of 6, 2 times 3. We cannot have that radical in the denominator, so we need to multiply the top and the bottom by the square root of 6. To get rid of that radical in the denominator, so square root of 6 times the square root of 6, we need to rationalize the denominator, getting that radical out of the bottom. So up top we have I square root of 6 all over, I'm like doing terrible job of the room here, but it's okay. So -1 square root of 6 times the square root of 6, you can write it as the square root of 6 twice the square root of 6 squared. That way the square root and the square cancel each other out. Up top we have I square root of 6 all over -1 times 6. The square root and the square cancel each other out. So we have I square root of 6 over -6. And whenever we have I is like a radical. So we have a radical and a radical. We always wanted to put in A plus BI form, where the I is at the end, it's kind of separate. So let's write it like that. So I have negative, because the negative can go on the top, on the bottom, or out front. So let's put it out front. So negative square root of 6 over 6 I, and that will be our final answer for this problem up here. Sorry, kind of went all around the world there. All right, let's do the next one. And the reason why I didn't cancel these out is because I was looking at the other examples, they're all not always going to cancel out. So I wanted to do a problem where if you didn't cancel them out, what happened? So that's kind of why I went about it in this way. So that way it doesn't matter what problem you have, you could do it like this. So the next example says express -100 minus the square root of -100 minus the square root of -64. So the square root of -100 we know is going to be 10i just by looking at it. We did that super fast. We know the square root is 10. The square root of 100 is 10, so 10 times 10 is 100. And we know the square root of that negative is I. So we could just go ahead and write it as 10i. Likewise, we have minus the square root of -64. The square root of 64 we know is 8. 8 times 8 is 64. The square root of that negative would give us I. So now we have 10i minus 8i. These are like terms, so I can combine like terms. 10i minus 8i would be like 10 minus 8 would give us 2. So 2i. It says write it as in terms of I as a complex number. This is fine just like this. So 2i would be our final answer for that one. So let's do the next one. Evaluate the expression 4 plus 2i plus 6 minus 7i. Write the result in this form A plus BI. All right, so there's nothing out front of this first set of parentheses besides a positive 1 to distribute, so it's going to stay 4 plus 2i. If we distribute this positive 1, it's going to stay plus 6 minus 7i. And then let's combine some like terms. So we have 4 plus 6, which would give us 10. And then, let me use a different color. We have 2i minus 7i. So 2 minus 7 would give us -5. So -5i. So that would be our answer in A plus BI form. So the real number is our A, which would be positive 10. And our B would be the number in front of I, which would be -5. Last page. Perform the indicated operation and simplify. So we have 16 minus the square root of -100 minus -6 plus the square root of -49. So let's kind of simplify this a little bit. So I have 16 minus the square root of -100, just like on the previous page. The square root of -100 would give us 10i. The square root of 100 would give us 10. 10 times 10 is 100. And the square root of that negative, the square root of the -1 would give us our I. Likewise, minus negative 6 plus the square root of negative 49. The square root of negative 49 would give us 7i. The square root of 49 is 7. 7 times 7 is 49. The square root of that negative is I. So now let's kind of simplify this. There's nothing outside of this first set of parentheses to distribute besides a positive 1. So it'll say 16 minus 10i. Then we can distribute that negative in front of the second set of parentheses. So negative times a negative would give us a positive 6. Negative times a positive would give us a negative 7i. So 16 minus 10i plus 6 minus 7i. Now combining like terms. So 16 plus 6 would give us 22. And likewise, negative 10i minus 7i. So negative 10 minus 7 should give us negative 17i. This is in the form a plus bi. Our I is last, so we're good. Final answer, 22 minus 17i. Next one, perform the indicated operation and simplify. Express your answer in terms of I as a complex number. 5i times negative 2 plus 7i. I could distribute this just like if I was a normal variable. So 5i times negative 2 would give us negative 10i. 5i times positive 7i. 5 times 7 would give us positive 35. I times I would give us I squared. Just like x times x would give us x squared, I times I would give us I squared. Now we know from this first page that I squared is negative 1. So I can use that. So remember that I squared is negative 1. So I can rewrite this as negative 10i plus 35 times I squared. We know I squared is negative 1. So negative 10i, 35 times negative 1 is negative 35. These are not like terms, so I cannot combine them. This one has an I, this one does not. But I want to write it in terms of I as a complex number, remember, so it's going to be a plus bi, so that I has to go last. So negative 35 minus 10i, putting that I last. So moving this up front and then moving this back. Getting closer, so simplify. Negative 4 plus 5i times negative 4 minus 5i. Notice they're conjugates, same terms, different middle signs, so we know stuff should cancel. Let's distribute like we would a normal polynomial. So negative 4 times negative 4 would give us positive 16. Negative 4 times negative 5i would give us positive 20i. Notice we did negative 4 times everything, so now 5i times everything, so 5i times negative 4 would give us negative 20i. 5i times negative 5i would give us negative 25. I times I would give us I squared. So 20i minus 20i cancels each other out. We set up here that I squared is negative 1. So I can rewrite this as 16 minus 25. We know I squared is negative 1, so plugging in negative 1. So 16 negative 25 times negative 1 is positive 25. And then last but not least, 16 plus 25 would give us 41. Then final answer is 41. Last example. Simplify the following expression, negative 8 plus square root of negative 4 all over 6. Give your answer in the form a plus bi. So we have negative 8 plus the square root of negative 4. We know the square root of 4 is 2, and the square root of that negative is I. So I can rewrite this as negative 8 plus 2i. The square root of negative 4 would give us 2i all over 6. That means both terms are being divided by 6. So negative 8 over 6 plus 2i over 6. Always simplify our fractions. Negative 8 divided by 6, they both have a 2 in common. So I can factor divide out the 2 from the top and the bottom. That'll leave us with negative 4 over 3, negative 4 thirds. Likewise, 2 divided by 6, they both have a 2 in common. So I can factor divide out that 2. That'll leave me with positive 1/3. And then writing that I out. So that way it's in the A plus B and an I is separate. So our final answer is -4/3 plus 1/3 I. So this is all of Module 4 Homework 2 notes. I hope this was helpful. You can now go ahead and complete Module 4 Homework 2 assignment. If you have any questions, let me know. If not, thank you for watching.